Okay, guys, let's do our wave and matter notes. These should be on page 90 and 91 of your notebook. If you don't get everything from the video, it is also in your text, section 14.2. So, we experience waves because they interact with matter. So, how do waves interact with matter? Right. We observe waves because they transmit energy, information, or motion, which is just another form of energy, over a distance without anything obviously moving. Okay? The air isn't obviously moving. There's no wind in this classroom because you're listening to my voice. The molecules are just compressing and refracting or rarefracting and causing that transmission of information, okay, in the form of the words that I am speaking. Some other examples might be your remote, okay? You can tell your remote to change the channel. It's a lot easier than walking up to the TV and pushing the button to change the channel. Wi-Fi, okay? Wi-Fi transmits tons of information. Whatever information for whatever Facebook post or Instagram post or BuzzFeed article that you were reading, it's transmitting that information through the air in the form of a wave. Okay? Radio, the music that comes out of your radio is transmitted by radio waves, which are very long electromagnetic waves. They get that information from the source of this sound, from the radio tower, to your car. Now, when a wave hits a boundary, and by boundary I just mean anything that is a change, okay? The wave can be affected in 4 ways. The wave, if you look at yourself in a mirror, the visible light waves that are coming off of your body, okay, are being reflected off of your body, more likely, are being reflected to the mirror and back to you. That's reflection of a wave. Okay? Sometimes the wave goes through the medium, but it's bent a little bit when it does this. That's called rarefaction. Okay? Sometimes the wave spreads out. Like if I stand outside, you can still hear me because as the sound goes through the doorway, it's going to spread out even if the door is only open to crack. Same with the light. That's called diffraction. And the last one is super important. It's how we experience color and how we charge, well, not really charge our phones, but wireless charging might be a thing. And that's called absorption. Okay? And we're going to talk about each of these 4 in a new box. I will show you demos and such tomorrow. So let's start with what is reflection. This is normally the one that most people are most familiar with because, we use mirrors quite a lot. Reflection is when a wave sometimes we'll refer to the waves as rays, bounces off a surface. Okay, and there's some things that words that we need to be aware of in this, so we're going to draw it. Okay, so there's my reflective surface. Okay. This perpendicular line is called the normal line, or it's what's normal to the surface, just means at a 90-degree angle. And say I have a wave and it hits right like that. Okay, that's my incident ray. Okay. And the wave is going to reflect off. Is it going to reflect off like that or like that? No, it's going to reflect off at the same angle that it hit. Okay, and then I have my two angles in here. Okay, I'm using the Greek letter theta, just like you do in math class. This one right here is called the angle of incidence. This one is called the angle of reflection. And when something is reflected, those angles are equal. Okay. The angle of incidence equals the angle of reflection. Okay, that's just how it is. They're reflected at the same way that they hit it. So other than the obvious example of a mirror, sound waves can also be reflected. We experience that as an echo. Also, if you're in a swimming pool and there are waves in the pool, they're going to reflect off the edges of the pool. That's also reflection. Okay. The next one, I just realized I wrote it wrong up here. It's not refraction. I wrote the wrong thing. It's refraction. So take off that, put an R in there. Sorry, fix that for me. Refraction. What is refraction? Okay, if you've ever seen this picture before with his head over here and his body over here, this is due to the refraction of light in the water. Okay, so when a light hits water, it bends and it causes some funny visual effects. Okay, so refraction is when a wave is bent as it passes through a material. Okay, so in this one, we're still going to have, there's our refraction surface. And let's go ahead and draw our normal line. Okay. There's our incident ray. Okay. So it's going in at an angle, and then it's going to refract. It's going to bend. Okay, that's our refracted way. Refracted. Okay, this angle that it hits at is still called our angle of incidence. and then this angle right here. Okay, that's called our angle of refraction. I'm willing to bet that some of you guys right now are using refraction. Okay, the light that is coming into your eyes is being refracted. An example of that is glasses. Okay, glasses work because the glass refracts the light. It bends it and makes it so it passes through your eye and the lens in your eye at the right thing. Okay, both telescopes and microscope makes use of lenses to refract the water. I'll show you a demo of this tomorrow, but that's pretty much what. Oh, a prism. A prism uses the different angles of refraction based on the angles of light to separate light into its colors. That one's pretty cool. All of those examples of refraction. Okay, next one. I have to go on to the next page, can't fit it on that page. And we have what is diffraction. So diffraction is when a wave bends around obstacles or goes through openings. Okay. We're going to do a lab about this eventually. But basically, okay, say I have this is called the diffraction grating, okay? Or you can just think of it as a hole in a wall, okay? And we have a bunch of light approaching it that can't go through there. But what's going to happen is it's going to get bent out, okay, in that cone shape as it goes through. You see examples if you use a flashlight, okay, the light spreads out, okay. Headlights on a car make use of the diffraction, okay. Sound going through a crack in the door, okay. All of these can be examples of diffraction. And last but most certainly not least is absorption. I cannot write. Absorption. Absorb is spelled with a B. Absorption is spelled with a P. Why? I don't know. English. So, this is what happens when a sound or light or something is absorbed. And kind of how that works is the amplitude, which affects the intensity of a light or the volume of a sound. It'll get smaller and smaller until you don't have the wave anymore as it travels through a medium. Okay, we often call that dampening. But what's cool about this is that energy from the amplitude of that wave gets absorbed into that medium. Okay, the wave's energy is transferred. Okay, so you guys saw this at the beginning of the year when I had that tank and I put the green light in it. So say you have your light and it's moving through, and then eventually the wavelength is going to get smaller and smaller until you have no light coming out the back. Okay, so you have a light or any other type of wave going in, but no light coming out. Some examples of absorption might be a sponge absorbing water waves. Okay. Another example might be a pillow absorbing sound. Okay, if you put a pillow over your head, it muffles the sound coming out. Or color is based by the different absorption of light waves. The color black, for example, absorbs all visible light waves. Okay, so that's absorption. I'll show you guys some demos of these tomorrow when I get back.